bouteille d'eau, s'il te plaît.
Il aura bientôt le signal.
Si chacun passe ses diapos, c'est bien.
Il faut venir ici pour le micro. One, two, one, two.
On prend notre temps. J'ai pensé pendant que je transmis le time, mais il va le dire.
Hello, everybody. Hello. I'm glad to be here with you to share ideas, project stuff about Ethereum. My personal impression, in 2003, I was a student, a CNAM student, learning how to develop and learning about software development. I'm Christophe, the head of the blockchain tribe at Octo Technology. Octo Technology is a French IT company.
I am Lou, a developer within the blockchain team.
I'm Maxime, me too, developer in blockchain team.
So, during our free time at the Octo Technology, we developed a little project on Ethereum, and we're using a service named France Connect. I will explain you what is France Connect. And we done some stuff with it, and we will present you our next time, the next step. What is France Connect? Imagine you use a website to do some stuff, and you want to log in. You can use your personal, your local login password, etc. Or you can choose France Connect services. France Connect is a sign-in process and based on OpenID Connect technology. You can donc choose France Connect and use different identity provider, like the Ministry of Finances, or like National Post Office, etc. You log in with your login password or credential, etc. And after, France Connect will use the identity information sent by the identity provider. And finally, transfer this identity information to the original website.
So in our case, BlockID is the service provider. So we are connected with the official French digital identity. So we receive some identity informations so we can access to all French public services, like say a proof of completion of an online initiative, proof of an administrative or legal decision. So it opens up some great use cases, but we haven't worked on this much for now. So what is this proof of concept is very basic for now. So we only attest that an Ethereum account is a French citizen. So without any other claim, and we try to add a better degree of privacy when we had some the user the choice to add many Ethereum accounts, so he can choose like say many services with one Ethereum account for each. So we didn't follow the standard or an existing platform, but we built it from scratch.
Now I present you the process to certify an account with a block ID. Here you have the user, and here you have the Ethereum network. The first step is that the user must be connected with France Connect. After that, he can access to block ID. At this moment, block ID knows the identity of this user. This identity contains first name, last name, birth date, birthplace, and gender and other information. All this information isn't stored by block ID. If this user wants to certify his account with block ID send generate secret and hashed this secret and send to a block ID contract. After that, this same secret is sent to the user, and this secret is unhashed. The user must be make a transaction with this secret to this contract, and after the block ID contract make a challenge with these two secrets, and the user identity is validated. And the identity contracts are generated. This identity contract contains some information, like address of certified account, if this account is certified, and some date, like first certification date, the last certification date, and the revocation date, if the user wants to cancel his certification. All this data, with all this data, we can't find the user identity and respect his privacy, like pickups or made by priority team. Now we are looking at how read this information, how services can read this information. We suppose that the user wants to connect to an apps or the apps, for example. These apps can make a call to a block ID register contract and find the right identity contract of this user. And after that, just make a call to this identity contract for have the right information. Now I present you some screenshots of this application. This is a login page. We can see the France Connect connector for logging with France Connect for connect to block ID. Here it's a page for manage and certify a new account when user is connect with after the user is connect with France Connect. The user can certify his account with multiple ways, like MetaMask or with his wallet. And there in this page, there are all this information for certify his account. And this page, we can see an account validate and all the information about this account. No.
In the blockchain or out of chain, block ID don't store any sensible information. We don't want to put address, government ID, age, or whatever. We only want to be out and store in the contract some information like one address, some date, but not sensible information.
So beyond this simple proof of concept, so we just demonstrated that we can be a proxy between France Connect and blockchain or any other ecosystem. So we are working with the France Connect team, which are part of the Interministerial Directorate of the Digital Information of France. So we would like to build together some use cases with them, because they don't know already how to create some projects which will require some identity informations. And why not plug France Connect to a self-sovereign identity platform?
Since 2012, self-sovereign identity architecture is working, and we want to be part of this ecosystem. Identity control access by any authority, not just put the user in the center of the identity process, but self-sovereign identity requires users are the actors, what is the term? Control of the own identity. So we want to become, with France Connect or with the French government, become a claims issuer. This is our goals.
So we looked a bit about on the existing platform in development. So in example, if we plug with Geoports, so we will be attestors. And so we could more or less do the same process as a Zug city based in Swiss. But with France Connect, we won't ask users to go to a record office so someone can review the submission. But we will just ask someone to log in to this website using his credentials. So you'll say, yeah, but it isn't as secure as going personally. Yes, indeed, with only login password, it isn't. But with ADAS, which is currently work within the European Union, you could have some level of authentication security. So today, for this simple POC, we only use the first one, but we could use the second one, which use two-factor authentication, or the third one, which was also a scan of your passport. And we are also following the standards working on by the W3C and the Decentralized Identity Foundation, Sovereign the Permission Ledger. So, thank you. So we have 2 minutes if someone has a question.
Hi, you mentioned revocation dates, but who does the revocation? On whose initiative does revocation happen?
So the user can, but you're speaking about the POC?
Yeah, so
Yeah.
I collect the claim that I'm a French citizen, then my citizenship is taken away, but I can still use the claim that's recorded in the blockchain. That was my issue with how it works.
Uh-huh.
So if revocation happens on the initiative of the user and not of the identity provider, then if the claim turns out to be false, because for example my nationality is taken away, or some other claim is not longer true, then as a user, of course I will not take away the claim, because then I lose abilities that I lose the abilities on the blockchain that I have with its identity.
So for me, that's the concept of self-sovereign. So he's in control. He can revocate his claim or not. Claim made by other
right, but
parties.
if I'm a relying party, if I use the login, then I want to make sure that the information is up to date. And if there's no revocation list, if there's no list of claims that have been revoked by the identity provider, then I actually cannot rely on those claims.
Yeah. So that's why we haven't stored any claims. We only say that this account is a citizen, that's all, because that was just a simple poke to plug to the Ethereum and the France Connect ecosystem.
What about historical claims? Was a particular address a French citizen 2 years ago, or at a particular time in the past?
So do you mean which type of claims?
Some claim in the past.
So we don't currently hold that. We want to rely on another platform and being issuer. So we will like follow the with JSON web token or things like that. So with expiration dates. But today this isn't implemented. Yeah. Yeah, right. So today it's only open to the public sector, but we are 2 or 3 companies in touch with France Connect. So they are going to open it to other private sectors. So we are part of the beta phase of France Connect. So we are testing with them how we can plug to existing. No, it isn't. It's in development. Yeah. Yep.
I just would like to know, did you look into the ESS 725 standards and ideas around that? Because it's like the same thing, right?
Yeah, we looked also. We don't spoke about it, but yeah, we can speak about it after, sure. Thank you.
Okay, thank you. Hello, how are you doing? I'm Andres Junge from Uport. I'm going to talk a little bit about Uport. This is not the classical Uport talk. It's more about what we think should be the Ethereum identity, what we think identity on Ethereum should be. We've been working in Uport since 3 years now. And when we try to approach the identity problem, we have seen a lot of different use cases and a lot of different definitions of identity. For example, for government, it's all about taxes. They want to have a number for you so you can identify you if you pay taxes or not. I'm from Chile, and in my country, the identity number, it's called tax identity number, so it's basically for that. Corporations basically want to identify their customers and their employees to give them different access to different parts of their system and to track how they pay or they buy things. Classical Web 2.0 companies, they use email, Facebook Connect, logging with Google. That's what they think identity is about. For fintech companies, it's all about KYC. Every fintech company here is facing in almost all jurisdictions all these anti-money laundering laws and terrorist financing laws. So it's basically all about knowing who is working with us or with them. For Ethereum dApps, it's an Ethereum address. They only need to know that. Sometimes they need to know more about who is behind that Ethereum address or who is in control of that address. And for NGOs, it's a form of verification, a valid form of verification. NGOs, mostly identity NGOs, are more focused on refugees because it's hard to track who someone is if they don't have any kind of identity. When we try to approach Uport, we always think about standards. We try to build something that can be used by anyone that is standardized. And you have a lot of different words that the problem we find out, it means different things to different people. So you find that some people think claims are one thing, some people think registries are one thing, attestations, identifier credentials. You will find all these different words. Sometimes it's the same meaning for different audience, but sometimes it's completely, or there's subtle difference for them. Identity standards. The first identity standards was made by the ITU. It's International Telecommunication Union. It's a very old one. It's a crappy one, in my opinion. The only thing that survives from that is the X509 standard. It's the thing we use for HTTPS, SSL, certificates, all the thing. Lucky for us, the Web 2.0 world came out with OpenID and OAuth, basically for identification or authentication and authorization. And basically, all the solutions right now are built on top of that. Facebook Connect and Google, logging with Google, and all the other stuff are built on top of that. And right now, we're working with something called the Decentralized Identity Foundation. Well, the URL is there. It's identity.foundation, so it's pretty simple. I'm going to talk a little later about that. Okay, there's some key concepts we want to address here. First is identifiers. What identifies someone or something? Because identity is not only for people. It's sometimes we want to have identifiers for other things like IoT devices or contracts, smart contracts, or pieces of land, right? So in our model, or in the DIF model, identifiers are called DIDs, decentralized IDs. Also, an important concept is the claims. Claims are things that someone says about somebody, or something about something. But it's a source make a claim about a target. People also call this reputation statement. And the claim always have a source and always has a target. We make a difference between claims and facts, because facts means that someone verifies that, or the source is verified somehow. I can claim that this audience is great, but it's not verified at all, or, well, probably. So if you trust me or do not trust me, that depends, that makes the claim more valuable or less valuable, right? Another concept we think it's important and we find out it's important, it's a way for asking for identities. The problem right now we're facing is that we have identities, but like the normal identity or government-based identities, are hard to present to a software or to a service. So the flow of how the identity flows from the owner of the identity to the consumer of the identity is something we need to address too. And also how to ask or verify for a claim. So we build Uport. Uport, we build it as an open identity platform. We want to be very open and make it useful for a lot of people. And we build on top of Ethereum. That's why we're in this conference and not in another one. Yeah. Okay. These are the key concepts for the Uport platform. First, for us, identity is an MNID. MNID is a concept we defined, which means multi-network ID. At first, we thought, okay, identities can be Ethereum addresses, but then we find out that the same Ethereum address can live in different networks, in different blockchains. We have now 4 blockchains, mainnet and 3 testnets, but also we find out that people have private blockchains, which makes it more difficult for everything. So MNID, it's a small encoding standard, or it's not standard, but it's something we put it to the community, which encodes the network ID and the address, so it makes it easier to understand if an address is from which network it belongs. It can be used for public-private key combinations, but also for addresses of contracts. We also built a proxy contract. It's optional, but it's a contract that allows people to manage their keys in a better way. We find out that people, first they use their Ethereum address as an identity identifier, but then if he lost his key, then he lost all his identity and all the claims for that identity. So we thought, okay, let's build a proxy contract that is actually the identity of the user, and then the keys can manage that contract. But it's an optional thing. If you decide to use another contract or another way to manage keys, you can still use the Uport. Also, we built a registry, something we think is a shared space where people can share public information or public claims for other people. And we propose a standard for that. This is the ERC 780. I'm going to talk a little more about that later. The other thing is that we want to use claims. We want claims to be signed by users and verified by other users. So we need to have all the public key infrastructure the same way we used to the old one, but without the certificate authority certifying something. We decided to build a public key infrastructure in a decentralized way. So we propose a way for doing that in a standard way. Also, for requesting claims, or for issuing claims, or for sending claims to the user, and all that stuff, we find out that there's no single easy way to do it. So we defined a messaging system which is JWT based, which can be signed by identity. So all these JWTs are signed by the identities, which public key is stored on the registry, which allow anybody to check if the ID is the one actually that is signing the JWT. Also, we made a way for requesting standard private data. That way allows users to select which information they want to share. So if I'm a dApp or a service and I decided, okay, I want to ask the name or the birthday from a user, and then the user receives that and he can choose to disclose that information or not. That's what we call selective disclosure. We need to have a really cool flow that allows the user to check who is actually requesting this information, and a way for giving that information back to the requester. All these claims, we also find out that not everything should be on the blockchain for privacy reasons and for speed reasons. There's a lot of use cases where people don't want to use the blockchain at all. They don't want to sign transactions. They just, or the contract, there are no contracts involved. Who wants to check claims or something? They're just users that needs to have an identity that's permanent somewhere. And all the information should flow in an off-chain way. So we built a format which we call attestations or credentials or, well, badges. We haven't decided a cool name. But still, it's a JWT standard which specs which claims are, which is the format for a claim. And also we are working with the Decentralized Identity Foundation, and they defined a standard for the DIDs, for the decentralized identities, and we built a compliant implementation for that. Okay. Okay, the Decentralized Identity Foundation defined something, the DID, the Decentralized Identifier, which looks like that. It's DID, method, and the method-specific identifier. This is basically because the DIF, it's a foundation that it's, their members are from everywhere. People from IBM, Microsoft, Sovereign, we, other people from Evernym also. So not all the solutions are blockchain-based. So and the standard, the DIF standard should support all the methods. So basically, that's the format for it. So our DIDs, the UPort DIDs, are DID, UPort, and the MNIT. This is how an MNIT looks. It's an encoded Ethereum address with the network. And there's also a thing called resolver. The resolver basically, given a DID, can resolve a DID document or a document of identification attributes for someone. Of course, these resolvers should only provide public information. In case we are asking for private information, then we should do a selective disclosure request. So the DID document contains public claims, public keys, endpoints for more identities. In case I'm storing my information in a secure enclave or secure hub, then I can point my user or the consumer of my information to that point. And of course, there's the resolver who resolves from DIDs to DIDs documents. Well, can you see that? This is our proposal of the registry. This is our version of the ERC 780 implementation, which is basically a registry. It's hard to read, but it's not that complicated. It's just a mapping of mappings. Yeah, but you basically store information for the user, which just think it's only public information. Our resolver, if you want to resolve the DID that it's written down there, basically you go to the registry, get what we call the UPort profile IPFS, which is basically return me the IPFS hash where the DID document lives. So basically, you give that, and it looks up in the UPort registry for the IPFS hash based on the MNIT of the user, and returns back. But this same registry can be used to store claims from somebody else, like if the claim is stored on IPFS hash, or if the hash itself of the claim can live there. So it's a multi-purpose registry for storing everything we find that should be public at all. Okay, we always thought that we shouldn't build anything that it's too monolithic, that it's a single thing, we always thought that we should build something layered, that we can change, or you can opt in to use some things. So on the bottom is Ethereum. We can build an optional access control layer, and also, as I said before, we can build we can run the UPort proxy contract as optional too. Then we have this MNID, which is mainly the DID, which is the identity identifier. And then, if you want to store public information for that identity, you can use the on-chain registry. If you don't, you don't. The public infrastructure relies on this, so if you want to use another way of doing public infrastructure, you can use another way of doing it, even a not decentralized or a centralized public infrastructure. Then we use IPFS for the document, DID document storage, because, well, IPFS is so cool. Kudos to them. Then we have built the DID resolver and the public infrastructure on top of that, and the off-chain claims, which is basically JWTs that are signed off-chain and flows in this system. And we have the selective disclosure flow and all the other messaging flows. We have opened everything except for one thing, which is the mobile app. Not because we don't want to, because it's not ready to be open source, but it's going to be open source soon. But all the layers are we have specified in the documents. We have demo apps. We have different kinds of JavaScript libraries that allows you to read from the registry, write on the registry, deploy contracts, and all that stuff. The main endpoint or entry point for this is developers.uport.me. Our proposal for the Ethereum registry is on the EAP 780, and mostly all of the repo information is on Uport project on GitHub. And of course, if you want to send us an email, just send us to team.uport.me. Or if you want to talk to me later, of course, I'm going to be here. There's also Paul. Paul, raise your hand. Paul is our partner manager. So he can, well, he speaks English better than me anyways. Oh, cool. OK. One last thing before I go to the questions is we started this kind of thing in the Ethereum conference when we have a QR code and people scan this QR code and they receive an attestation that they were there. That's actually not true because it's not really a proof of a presence, but it's a cool thing and people like it. So if you have the Uport app installed, you can scan the QR code and you will get an attestation, an automatic attestation that you have seen the QR code. Because people in the streaming are also seeing this QR code. How this works? Well, basically, the QR code is a selective disclosure request. So your phone gets their request that someone is requesting an attestation, that someone is requesting information from you. Basically, what we are requesting is your Ethereum address, or your MNID, or your DID. And also, we are requesting push notification tokens, so it allows us to send the token or the attestation back to your phone. So yeah, I hope it works. If it don't, just let me know. And that's it. I'm going to leave it through the questions, so you don't need to rush for the scanning. Do we have time for questions? Cool. Thank you.
I'm just wondering with the ERC 780 claim registry, how you store IPFS hashes when they're traditionally multi-hash, which is more than 32 bytes long. I'm also wondering why that QR code is so enormous.
Well, we encode the IPFS hash. We don't store the ASCII codes. We just do a base 58, I guess, encoding, so we can store in 32 bytes.
Bytes, and then the hash itself is 32 bytes, but then they also have a multi-hash prefix which tells you which hash algorithm to use and so on.
Well, I need to check the code, how it's done, but, well, we can store it in the... Right. Yeah. And why the QR code is so big? Because the JWT that we are putting in there is first signed. There's the signature of it, and it's also requesting, well, it has the callback URL and also everything else that is requesting. And you can decode it. It's not that complex. You can check. Thank you.
Yes, thank you very much for your presentation. It was very nice. I also read the ERC 780 and I commented also on it. And I was wondering, if I read it correctly, you want one contract for every chain, one ERC 780 contract for every chain.
Not really.
Okay.
We are using one for our implementation, but people can use their own. Well.
Yes, because how I see it is it would be nice if there would be one per use case, perhaps, or yeah.
Yeah. If you're a tester and you want, for example, the question that they asked the later talk about how to revoke things, you can use the registry to revoke things. And probably if you are the attester and you want to have your attestations there and your revocations also in your own.
Yeah.
Yeah. And with different logic, probably.
Yes. Okay. Thank you very much.
Yeah, sure. Thank you.
Hello, I'm Alex Mohammed from Remy. And during DEF CON you mentioned that users don't like to create first their accounts using Uport. So do you think it is better to start implementation from the business side or service side? For example, like crypto exchange will implement Uport and after that offer users to use that system?
I don't think I get the question. So you're basically asking if I think the adoption will go from services asking people to use Uport or people with Uport asking businesses to say, hey, I have Uport, why you implement that?
Yes, because as far as I know, you already, during a few years, developing Uport.
Yeah.
And now user should create account.
We are seeing more people, or I mean businesses, companies, or institutions building their solutions on Uport and telling their users use Uport. We don't have a big Uport user base right now to come to that is relevant to an app. So people build their Uport integration first and then ask their users to use Uport. That's a problem we have. Like my mother, for example, installed Uport and says, okay, what do I do now? Nothing, really. If you don't have a site that you can use, there's nothing to use for it. So, but for example, Zug, it's they build all their attestation system with Uport, and then they ask their users, okay, install this app, because, well, they need to store their claims and their IDs somewhere. But they're also building their own app based on this standard specs.
And what about potential customers from traditional economy, not from crypto space? Are you going to work with such companies?
Yes, of course. There's a lot of companies that have show interested in this, not from Ethereum address, or for Ethereum ecosystem, but most from from Web 2.0 places. They only want to use libraries. They don't want to know where the identity is stored or where the claims are. It's just like, okay, as long as I can provide an easy way for people to log in and not managing all the users myself, great.
And one more question. Are you still making authentication with, do you need transaction for each authentication?
No. One thing we decided is that we thought that doing a transaction for every signing a claim or revoking a claim, or, well, revoking a claim, no, but signing claims or showing claims or presenting claims to user, doing a transaction for each one of those operations, it should be very costly. So that's why we decided to move everything off-chain all the attestations are off-chain. All the selective disclosure flow is off-chain. Right now, for example, you are not, if you scan this QR code, you'll receive an attestation, and that is, there's nothing on-chain on there. There's no transaction involved. Still, if you want to load the, or store your attestations or some public attestations in the blockchain, you can still use the registry to store there, and there will a transaction be involved.
Okay, thank you.
Cool. I think we have 2 minutes more, or I don't know. Yeah? Over there. You need to have the mic because the streaming, they don't get it. Sorry. It's not my rules.
So, my name is Nitika. Great work at Uport, firstly. I was just thinking that do we have a KYC, a complete KYC module coming up on Uport? Or are you waiting for developers to develop that and then you integrate with them?
Good question. We are experimented with some KYC solutions in-app that allows you to basically send your information, like your passport or whatever, along with your DID to a provider that will do a KYC for you and issue an attestation back to you. We are still experimenting with that. We don't know if we're going to put it in the app at the end, but everybody or everyone that wants to build such case like Tug or France Connect or everything else, they can do it on their own. There's no need to do it on the app.
Fine, got it. Thank you.
You're welcome. That's it? Okay. Thank you very much.
Good afternoon, everybody. Well, we'll talk about identity on the blockchain again. I'm Fabrice Croiseau. I'm CEO of Intech, a company, a Luxembourger company. We are developing a specific software and with few of them around the blockchain. And I'm also chairman of the board of directors of InfraChain. InfraChain is a non-profit organization created by the Luxembourg government, but now we are going on a European level. And our goal is to provide documents, guidance, standard to make private blockchain projects that are compliant with existing regulation and governance. We have a website, infrachain.com, with some existing documents to help people developing private blockchain to be, for example, GDPR compliant regarding data privacy, while keeping decentralized trust on this private blockchain.
Hello, everybody. My name is Antoine Detente. I'm working in Intech too. And I'm working on different projects related to blockchain and decentralized architecture.
Fine. What do we want to do around blockchain and with digital identity? Our vision is that it's possible to use blockchain. It's possible to use blockchain as a technical platform to manage digital identity in a trusted way, the same way that it's used today with strong identities with digital certificates and PKI. Today it's already possible to have a digital identity with a high legal value that you can use to sign documents, to authenticate on website, and this authentication and this signature have to be accepted by any court in Luxembourg, in Europe, If the certificate has a certain characteristics, if they are qualified certificates, it exists since a long time. It's mainly used in enterprise. Is there anybody here who have digital certificates, X509 certificates, that it's used to connect to website or to sign documents? Well, nobody. But this standard exists since a long time. But if some of you are Belgian citizens, Luxembourger citizens, or even Estonian citizens, you have this kind of certificates on your ID cards. But since the technology is quite complex to install and to use, to authenticate or to sign, it's not used. But it exists. And the good things with this certificate is that the KYC, a strong KYC, so KYC is know your customer, is all the verification steps and process that have to be made to make sure that the owner of the certificate is the person that is supposed to be the owner. These steps are already made strong with legal value, so it already exists. And as you will see, we will reuse these characteristics to link this certificate to a blockchain address. So the drawbacks of this technology is that it's not flexible at all. The technology is complex. It implies to install lots of things on the computer. It's also difficult to use. Even when everything is installed, you have one times on two, it doesn't work. It's still centralized, and it's also expensive. Having such a certificate costs around 80 euros, a qualified certificate in Luxembourg, for example. And the kind of identity that I presume all of you may have is that identities that are given by GAFA, by big players. They are identity provider because you have account and you can reuse this account to connect to external third-party services by using OAuth2. But there is also some drawbacks. There are also some drawbacks with this kind of identity because it's not shared between all providers. There is no validation of identity data. With the previous one, with certificates, there is a strong validation of identity data that are stored on the certificate or the certificate. Here, there is no validation at all. I can create a new Facebook account named Nicolas Sarkozy or I don't know what. It's not verified at all. And it's still a centralized model. So you can have resilient censorship. People can remove access to your account if they want. So there are also some drawbacks. And when we compare what is feasible with, so the EDDITS, it's the name of our platform. It stands for Ethereum Decentralized Digital Identity Trust Services. It's blockchain. You can replace it with blockchain. We can have all the advantages of both technology, social networks, identity, and PKI with blockchain. So you need asymmetric cryptography to be able to own a private key, a secret that you use to connect or to sign documents. And the asymmetric cryptography is used by PKI, it's RSA. But blockchain is elliptic curve, but it's also asymmetric cryptography. You have strong security because, as you know, it's not possible to alter data that when they are on the blockchain. There is ease of use. Today, we can't say that blockchain is very easily usable by anybody, but in the near future, we can envisage that we will have blockchain wallets that are very easily usable and that anybody can use to connect blockchain to sign transactions. Today you have MetaMask. It's not very user friendly, but it exists. It works. And our goal, our vision is that these blockchain wallets will be used to store identity secrets that will be used to access to documents, to sign documents, and to authenticate on any web services. It's deployed everywhere because the blockchain is decentralized. It's very easily accessible by any computer in the world. And the legal value already exists in PKI. Today we are working on making our solution compliant with the regulation that has been mentioned just before, named ADAS. And we see it's possible. We have to go to the authorities, to the certification authorities, to define the process of certification, but today we have not seen any any obstacle to make this kind of solution validated and eIDAS compliant. So I leave the microphone to Antoine, who will describe what you have developed and what is working now.
Thank you, Fabrice. So, as Fabrice said, we try to imagine a new platform for managing digital identity in a decentralized way and using existing standards. So, for such a platform, what we need to use as building blocks. We need an identity support. We need something that you can present, like a passport, for example, like you can present to attest your identity and to be authenticated on different places. We need a way to request, to store, and to verify identity attributes. A way to add some data on your identity and present this data to other party. We need strong authentication because we need a way to prove that you are the owner of the identity, the owner of the keys, and you are the only one who has access to the identity. And we need, finally, standard SSO protocol because we want every online application can be integrated with edits, with the platform, can use edits to authenticate users. So we have to use standard single sign-on protocol. So for the identity support, we start from the standard or the draft about specification ERC 725, which concern identity and is a way to represent an identity in the Ethereum blockchain. ERC 725 is a smart contract. Each user has a smart contract with a defined interface. And this identity contract can hold the key you will use to interact with the identity, and is also a kind of proxy to send transaction to other contracts in the Ethereum blockchains. For the claims part, the attestation and the user's attribute, we use ERC 735 specification. We built a smart contract based on this specification. ERC 735 is a way to hold your claims, and defines the way this contract interacts with the other contracts of the platform, of the Ethereum blockchain, how to request a new claim, how to verify that a claim is valid or not, and how to access the data inside a claim. For the purpose of this prototype, this proof of concept, we need a claim issuer. The objective of the claim issuer is to produce a claim that you can attach linked to your identity. So we build a claim issuer which allows user to link a digital certificate, a X509 certificate, to a blockchain identity. It's a smart contract, publicly accessible in Ethereum. And when a user wants to request a new claim, he has to sign with his digital certificate. He has to sign his address, his identity address, and send the RSA signature to the smart contract. And the smart contract into the chain validates that the signature is correct. And if the signature is correct, the smart contract extracts the user information, the first name and last name, which is present in the digital certificate, and create a claim and link these claims to your identity, to your ERC 725 contract. For the RSA signature validation, we use Modex precompile contract, which is available since a few months in Ethereum, since the Byzantium fork of Ethereum. So we can build this proof of ownership of a digital certificate in a trustless way. You don't have to trust anybody. It's the code of the smart contract is publicly available, and you have to put a digital signature into the smart contract to have this link to your identity.
What is interesting is that you only have to trust the certificate issuer, that is the state, for example. You don't have to trust two actors, as it is often the case. For example, if you see the example that has been presented, just not the presentation before, the one before, you have to trust France Connect to have the right information, but you also have to trust block ID to use to not alter this information when they transfer them from France Connect to the blockchain. So you have to trust two actors if you don't have to trust any actors except the one that has issued the certificate with a public identity if it's done by the state.
Thank you. So we have the identity support. We have the way to request and to add claims on this identity. We have some claim issuers, the first one in our platform. We need a way to securely access ECDSA key. It's a key point of having secured key to access this identity. You can use hardware wallets like Ledger or so on. It's secure because you have two-factor authentication to unlock the key and to have access to the contract. But the challenge here is to have a way to prove in the chain that the transaction has been signed by a strong secured ECDSA key. A way to be sure in the chain that the transaction is coming from a two-factor protected ECDSA key. For this purpose, we are working on a prototype. We are trying with FIDO UAF authenticator. I don't know if you know what is FIDO UAF. It's FIDO is open standards about authenticator and the way to register a new authenticator and how to interact with authenticator for web application. It enforces two-factor authentication for web application, and we are trying to work on a prototype with this kind of authenticator to unlock an Ethereum key and to prove in the chain, in a smart contract, that the transaction is coming from FIDO UAF protected keys. And finally, we need a way to build a single sign-on protocol to interact with online application. So we commonly used GW2 token. When a website wants to authenticate their users using our platform, the user is redirected to edit, to the web application, to the dApp, and can sign a GW2T token with one of his keys. And on the other side, the web application has to validate that the token is valid, is right signed, and that the key which signed the token is registered on the identity on the ERC725 contract.
Here again, the idea is to use the wallet, the blockchain wallet, but not to go to the blockchain, only to sign the transaction. We will use a private key stored by the wallet with ideally strong authentication, two-factor authentication, to sign the authentication request, but without, we won't go to the blockchain. We'll directly send the signed information, it's not a transaction, to the website that has asked the authentication.
Okay, so we have the three parts. We have the identity support, the strong authentication using hardware wallet, or maybe if we succeed with the proof of concept with a FIDO UAF authenticator. And we have standard assertion in the form of GWT tokens. So what does it look like? And I will present quickly the current platform. I cannot make a live demo, but I have some screenshot to show you the process of adding a claim to my identity. So quickly, we have an ID management app. It's a basic web application in JavaScript, which runs in the browser. We have a third-party web app who wants to authenticate users using Edit's platform. And we have claim issuer. For example, a PKI certifier, which allows to link a digital certificate to my blockchain identity. So the first step is to deploy your own ERC725 contract. So you build the contract. The dApp allows you to deploy this contract in the blockchain. It's running on the Kovan network right now. I don't know if we can see something, but and when your contract is deployed, you have a basic user interface allowing you to use all the functionality of ERC 725 contract. You can add keys, remove keys, you can duplicate keys, you can manage the key type because in the specification we have a key by purpose. We have a management key, we have action key, claims key. So you can add keys, you can review all the keys that are linked to your identity. And you can request a claim. I will request a claim. I will request to link my digital certificate to this identity. But this certification process has a cost. You have to send a little of SFR to the smart contract to be allowed to link your digital certificate to the identity. So the first thing I have to do is to I don't have this step in the in the screenshot, but you can send money to the identity, and this money is stored on your contract, and you can send Ether to other address in the blockchain on behalf of your identity contract. So here I have to add keys, which is a claim purpose. The keys is the address of the smart contract, the PKI certifier smart contract. So I add the key into my identity, and I request a claim using a drop-down. We don't see anything, but I request LuxTrust claims. LuxTrust is the authority certification we use in this proof of concept. So the user is redirected to the LuxTrust portal. He enters into the authentication flow in the LuxTrust portal using the digital certificate, using a smart card or a signing stick, which is plugged into the laptop. And after the LuxTrust authentication flow, the user is redirected to Edit, to our platform. And we will present the information we extracted from the signature. We present the common name, so the first name and last name of the user. We also have the email address, different data, different user information that is present into the certificate. And if the user is OK to add this information linked to the identity, it just has to click on the confirmation button, and the transaction is sent to the Ethereum network. We use the MetaMask integration for this. So just the MetaMask pop-up is displayed, and the user has to confirm the transaction. When the transaction is mined, we can see in the list of the claims that there is a new claim, which is an information issued by the claim issuer, which is a smart contract. And you can click on the detail to call the LuxTrust here smart contract to extract the information of the claims. And the information is my name, my first name and my last name, and the certification authority which has delivered the certificate. So you can see that in a trustless way, I can link my identity and my digital certificate. The information which is present in the digital certificate has been validated by LuxTrust in this case, but following a fully documented process, and you can trust the information that is present in the certificate. And the goal here is to link this information with my identity in a trustless way. Thank you very much. You can go to the edits.io website and see a working version of this running on Kovan testnet. And if you have any question, we are available.
All this is a proof of concept because it's on the Kovan network, but all these features are already working. Today we have only linked the LuxTrust certificate, but we plan to link other identity provider to the platform. And all the source code is, we will put the link of our GitHub source code. It will be accessible. Our goal is to share this and to make this platform or this kind of platform really used to provide strong identity on top of the blockchain, and we're open to comments, or also if some of you want to participate to the project, you are welcome, because we are really confident that when we will have some easily usable wallet, it will be one of the different ways to have strong identities and to have legal values on top of signature and authentication easily usable by anybody. Thank you.
So I'm trying to figure out how this improves the usability. So for example, currently or until now, I would have to go to a certificate authority to get a certificate and then access my bank. I will probably still have to do this with your setup. I'm trying to figure out how this improves the usability. Thanks.
So, well, yes, today, if you don't have any certificate, you must get one. And after, when you have it, you will use your connection interface that is often specific to the certificate provider. That is why the X509 technology is complex. You will use this interface to connect to the platform and to link this certificate to the identity. Normally, we should be able to even to link a bank account, because any bank must perform KYC. Okay. So when you have a bank account, they have performed KYC on top of your identity. Imagine we are able to link any bank account to the blockchain address, at least conceptually. I don't know if it will be accepted by any court, but conceptually, the KYC of the address has been done because you have proven that you are the owner of the address, Ethereum address, the Ethereum 725 identity, and the owner of the bank account. So the KYC has been performed. Today, the KYC information are not shared a lot between actors of the financial sector, but there are some companies who are developing all the information system of a startup dedicated to perform the KYC for any banks. So what they do is they collect every document, and after they share them with the banks where you want to open your account. The advantage is that when you want to open 2 or 3 accounts in 3 different banks, you have to go to only one actor with all your ID documents. When your ID card changes, you have to give the information to only one actor, and he will share among everybody in a standard way. But with this kind of infrastructure, it will be more easy for them to share this information in a trusted way. So the question is, how do we handle 2-factor authentication? And you want to answer, or I start?
I can start. For the moment, we don't have a solution to handle this, honestly. But the objective is with FIDO Authenticator, you can have ECDSA key inside the authenticator, and to unlock this key and to make a signature, you need to execute the two-factor authentication phase. So it will be possible to do the two-factor authentication process, to unlock the key which is inside the authenticator to sign a transaction. The problem we have with FIDO for the moment is the registration part, because you have to run a FIDO server which must implement the FIDO certification, and to have this kind of server in a trustless way, in decentralized way, it can be problematic, and also it can be very expensive in terms of gas and fees of the transaction.
Yes, that's it. So as you said, today is already possible to have 2FA to connect to blockchain. If we use Ledger, for example, we have 2FA. The problem is that it's not possible to verify on the blockchain that this address is connected to either to a Ledger wallet or to any other two-factor authentication device. We don't know that on the blockchain. With what you are building on Fido, it will be possible in the near future to verify on the blockchain that the address that has been used to connect, that has been connected to the identity, needs two-factor. It's only possible to use a two-factor authentication to use this address. So if you have some other question, we are still available. Thank you very much.
Il y a un panel avec vous.